Alright, today we're going to start our last chapter of the year, and it's chapter 8, where we're going to be talking about linear functions. So if we kind of break down that word, linear means line. So we are going to be focusing on the equations of lines today. And the difference between the equations we're looking at now and the equations we've looked at in the past is most of our equations are going to have two variables, where in the past we were usually just working with one. We just had an x, or maybe we just had a y or a k. Most of our equations are going to have an x and they're going to have a y. So if we jump into our vocabulary here, our first one is a relation. What a relation is, it is a pairing of numbers in one set called the domain with another set called the range. Now, we have worked with ordered pairs before where we have an x comma y. So maybe we have 1 comma 2 or negative 3 comma 4. These are relations. They are a pairing of numbers. Okay, the 1 is paired with the 2. The negative 3 is paired with the 4. I have an x paired to the y. Now the x values are what we usually consider my domain. They are all possible inputs for the relation. So whenever I'm plugging numbers into my equation, these are members of my domain. Now whenever you plug a number into your relation or your function, the number that you get out is called your range. So the set of all possible outputs for the relation is what we call the range. So the domain are the x values, the range are the y values. Now we have a relation which just pairs two numbers together, and then we have what's called a function. This is probably one of the most important vocabulary words we talk about this year. You're really going to need to commit this one to memory. What a function is, it is a relation if for each input there is exactly one output. So what I mean by this, a lot of the times they will draw a function or a relation using two bubbles. Okay, so let's say my x values are 1, 2, and 3. My y values are 4, 5, and 6. And if I want to map the x values to a y value, let's say I map 1 to 4, 2 to 5, and 3 to 6. So I want you to notice that each x is mapped to just one y. An example of one that would not be a function, let's say we go with the same set of x's and y's, but instead I map the 1 to the 4 and I map the 1 to the 5. And then I'm going to map the 2 to the 4 and to the 6. And then maybe I map the 3 to the 5. So what I want you to notice here is that the 1 is mapped to two places. The 2 is mapped to two places. And although the 3 is just mapped to one place, these two, since they're mapped to two places, automatically makes this not a function. Okay, so every x is mapped to exactly one y. Okay, so let's look at this first example here. I have this table that tells me I have x values of 2, 4, 6, 8, and 10. I have y values of 0, 1, 0, negative 1, and 0. So the first thing that I want to do is I want to identify my domain and my range. Now for shorthand we can just use D and R, and then we're going to use what's called set notation. So we're going to use little brackets. That's really ugly. Let me retry that. Use little brackets, and we're going to put all the members in the domain inside this set of brackets. Now remember, if we think back to our vocabulary words, my domain are all of the inputs, or it's all of the x values. So all of these numbers here are the members of my domain. So my domain consists of 2, 4, 6, 8, and 10. The range are the outputs. So whatever this function is or whatever this relation is, when I put in a 2, I get out a 0. So 0 is one member of my range. When I put in a 4, I get out a 1. When I put in a 6, I get out a 0. Now I already listed 0, so I do not need to list it again. When I plug in an 8, I get out a negative 1. And when I put in a 10, I get out a 0. Once again, it's already listed, so I do not have to list it again. So my range, I only have 3 values. Okay, we're going to use this same concept up here, and we are going to represent this as a graph and as a mapping diagram, which is what I showed you over off to the right. Now, if we want to represent this as a graph, it doesn't really look like it, but these are actually all ordered pairs. I have an ordered pair 2, 0. I have an ordered pair 4, 1, 6, 0, 8, -1, and 10, 0. I have 5 ordered pairs there. So what we're going to do is we are going to represent these ordered pairs just on a graph. So my x values range from 2 to 10, so 2, 4, 6, 8, 10. And I have y values of 1, 0, and -1. So I have to plot my first point at 2, 0. My x coordinate is 2, y coordinate is 0. So my first dot will go right 2 and will stay on the x-axis. Then I have 4, 1, so we'll go right 4, up 1. I have 6, 0, so we'll go right 6 and stay put for the y value. I have 8, -1, so we'll go right 8, down 1. And then I have 10, 0, so we'll go right 10 and nowhere. Now we don't really have to connect them. You could connect them if you want, but don't really have to do that because we just wanted to plot our points. Now I also want to represent this as a mapping diagram, so this is where we're going to use our 2 bubbles. Okay, now my x values, or the members of my domain, we're going to list those in that left bubble. So I had 2, 4, 6, 8, and 10. The members of my range, remember I just had 3 of them. I had 1, 0, and -1. So what we're going to do is we're going to draw a line from my members of my domain to whatever they're mapped to in my range. So remember 2 was mapped to 0. 4 was mapped to 1. 6 was mapped to 0. 8 was mapped to -1. And 10 was mapped to 0. And I know it doesn't ask this, but let's think about this. And we think about the definition for a function. I want to decide, is this a function? So remember, I have every x value can only be mapped to one y value. So if I look at all of my x values, 2 is just mapped to one y. 4 is just mapped to one y. 6, 8, and 10, they are all only mapped to exactly one y. So if we were asked, we could say that yes, this is a function. Now it's tempting to say it's not, because I noticed that 3 different things are mapped to 0, but I don't really care about the members of my range. I can have more than one thing mapped to the same thing in my range. What's important are these x values here. Every x can only be mapped to one y. Okay, so this would be a function. Now, if we look at these graphs and I want to tell whether they're each one is a function, we can use what is called the vertical line test. And what the vertical line test tells me is if I have a function, or if I have a relation, so let's say this graph here and I want to decide if it's a function. If I can draw a vertical line through this function, so vertical going straight up and down, at any point in time, and it only crosses once, every single place, it's a function. So notice that anywhere I draw this on this relation, it's only going to cross my line once. So let's look at an example of one that's not. Let's say this time I have a relation that looks like this. Now I can draw a vertical line here, and it's only going to cross once. But notice that if I draw a line here, it's going to cross here, here, and here. So it crosses 3 times, so this relation here would not be a function because it does not pass the vertical line test. This function here, or this relation here on the left-hand side would be a function because there's no spot where I can draw a vertical line that's going to cross more than once. So if we look at these examples that we have here, I basically am asking myself, can I draw a vertical line anywhere and it's going to touch any two of those points? So if I look at this one on the left, hopefully you notice that if I draw a vertical line through x equals -2, it's going to cross at 2 points. Since I can draw a vertical line and it's going to cross at 2 points, it is not a function. If we go over here to this one, I have 5 points here. So if we draw vertical lines through all of these points, that one's okay, that one's okay, that one's okay, and those ones are okay. So notice that I drew 5 vertical lines through my 5 points, and none of my lines crossed through more than 1 point. Since I passed my vertical line test, this is a function.